negating quantified expressions. Now, there are scenarios where negatives will play a role in simplifying equations. Now, by convention, even though you're going to see it here a little bit, by convention, a quantified expression does not start with a negation, by convention. If you start with it first and then you change later, that's fine with me, but we need to change it. So there's no negation symbol at the beginning such as this. This really would not be accepted as an answer. Change it afterwards, then give me that answer, fine. Now, but because of some properties called De Morgan's, you've heard that before, we're actually able to do a very simple switch, and it's going to mean the exact same thing. And if you can believe it, it's going to be switching from either our universal to our existential or vice versa. Now, we'll show you that here in a second. But also symbolically, you're going to see this happen as well. By the way, you still see our double negatives that we would have in front. We've done that before. That would end up still, so that still works with negatives. But if you have, well, frankly, what you're going to see here is you're going to see our negated universal set of j of x is going to equal our existential, but negated function of j of x. So notice the pattern that we've got here. Now, here's one thing that a lot of things in the book kind of skip over and stuff like that, is the stuff inside of the actual propositional function will change too. So you'll see that in the next slide here, but I want to make sure that's perfectly clear as well, because right now we're just focusing on the overall function setup, but not really inside of it quite yet. So here's what we have for negating our universal function here. So we have every student in your class has taken a course in Java, okay? We're not changing that, that's just the overall setup for that. But we may have a situation where not every student in your class has taken a course in Java. Well, that would make sense just to put the negation at the very front. But here's the deal. I can get away with the same exact thing and really honestly make it easier on us when it comes to setting up some equivalencies later on. You know about equivalencies already. We've got more coming up. We could do the exact same thing if we say, hey, there is a student in your class who has not, there's a not coming into place or negation here, taken a course in Java. These two mean the exact same thing, but yes, they are swapped when it comes to their overall quantification. That's it. Same thing with existential. All we do is do the flip between the two symbols. We make the not inside of the function here. No student in your class has taken a course in Java, or every student in your class has not taken a course in Java. I hate the wording of that, but still, it's about right. Let's put it that way. So notice just the switch of our symbols, or quantifier symbols, and negation of where it's placed. Welcome to De Morgan's. De Morgan's looks exactly the same as what we have for propositional functions as we have here for quantifiers. That's the funny part, was where the distribution of the negative sign was, and then there was a symbol switch. Well, that symbol switch matches, remember, ands with our universal and ors with our existentials. That looks familiar too. So that's why we have our De Morgan's laws for quantifiers, especially for negation. So it's everything I basically just said in a nice, very nice table here. So here's a couple of examples of negation at work. Notice I'm trying to show you each example. I've used existential or universal, and then where we get to our longer problem here. Don't make it overly difficult. You know you're going to switch the sign, but you're also going to end up negating whatever function is inside here, just like we have in the examples here. But also, here's the other part I want to make sure we understand, though, is notice I did the negation here, but that negation, if you're given the function itself, we can also go ahead and negate whatever the value, or sorry, the conditional that was inside of that propositional function. That will do exactly the same. So notice there was an internal symbol change if we were given the exact formula for what was inside of that propositional function. The other one that we have here, same idea. This time we are given one that has the definition for the function itself. We negated it by frankly just switching around what the symbol was, and that's going to do the exact same thing as if when it was negated using a different quantifier. And then finally, this last one here, this is what you're going to see when you start giving some, Well, prove that this is equal to another thing. That's going to start showing up too, so just a heads up. And notice this one uses De Morgan's for law for quantifiers, and then we have our CDE that we talked about in the last chapter. So, whew, there's going to be a lot of work when it comes to these. So here comes the questions. You got two of them. You're going to negate both of these, which is really not going to be too hard here. So you're not doing the proof quite yet, so just hang in there. We'll get to that. So do the negation of these two, and we'll go over and answer here in a moment. All right, so step by step in the overall setup for number one here is, again, I started with this one and I'm going to negate it, so I have an item out in front. You know by precedence that we got to take care of the quantifier first, and this is our existential. So first, we're going to denote that using negation is within the quantifier. So we need to go ahead and get rid of that. So that's why we're going to use De Morgan's law for quantifiers. We're going to go ahead and change the symbol, and then we're going to make that internal part. And remember, this is all one piece here, using the parentheses here, of making that a negative. Now, we're not done yet, because then we can use our regular De Morgan's law back in last chapter to go ahead and make it actually a little bit more simpler and making both of those functions negative. But there is our switch of our conjunctive, so now disjunctive. So heads up when it comes to that yes, we're using two different sets of De Morgan's laws, one for propositional and one for quantifiers. For this last one, it was actually only two steps. First, after we did our negation with P of x and then our implication of Q of x, we have two steps for this. First, it's going to be that, well, now we're going to switch our symbols to existential, and then we're going to place whatever's behind it into our negative negation here and in parentheses. But actually, that kind of helps us, because I'm able to use CDE that actually requires a negation and these overall setup with the implication, and do our switch there using our equivalence in CDE to go ahead and have it as our existential. P of x is an OR of our negated Q function.